Go through a couple of examples, all relating to type 2 compounds. So we're going to look at a type 2, which is of course always a metal bonded to a nonmetal, and the metal, you don't know the charge of the cation. And we're going to also look at type 2 with a polyatomic. And I'm going to work through both formats. So I'm going to start where I've given you the compound and you give me the name, and then I'm going to also practice going from name to compound. So the general rules that you want to keep in mind for a type 2 is that the reason why you're dealing with a type 2 is that you have a metal bonded to a nonmetal and you don't know the charge of the metal. So it's not in the first or second family, it's not silver, and it's not aluminum. For the most part, you can count on it being one of the many transition metals in the periodic table. And so what you do is you use the charge of the nonmetal to balance out the entire compound and determine the charge of the metal. And then if you're doing your writing, you identify the charge of that atom using Roman numerals. So for the first example, I'm going to go through CuSO4, and we're going to go from naming using the compound to giving the actual nomenclature name. And you want to try to practice these specific steps. This is what will be most helpful. So the first thing I do is that I identify who I have present here in the compound. I know that copper is a metal, and I don't know the charge of it because it's not in the first or second family, it's not silver, it's not aluminum. So now what I need to do is I need to identify the other portion here that it's bonded to. And this is not an individual atom, it's a group of atoms. So this is my polyatomic. And SO4, if I look on my polyatomic chart, then I know that SO4 collectively has a 2- charge. And this right here is called sulfate. So this I get from my actual nomenclature formula chart. And so I know that I only have one copper and one sulfate, and the entire sulfate has a charge of 2-. And so in order for this 2- charge to be balanced, this entire copper, I only have one atom of it, it needs to have the same equal but opposite total charge. And so in this case, it's just a 2+, because this entire thing right here is a 2-. I only have one of it. I only have one copper, so it's going to end up carrying that entire 2+ charge. Remember, I want my charges to be equal but opposite. My total charges need to be equal but opposite. So in this case, the name is going to be copper, uppercase, 2 in Roman numerals because that identifies the charge of the atom, and then sulfate. And please remember, you want to do this uppercase and this lowercase. Let's do another one, Fe2O3. So for Fe2O3, again, the process that you want to use is you want to identify who do you have involved here. And so you have Fe, this is iron. You don't know the charge of iron. It's not in the first or second family. It's not aluminum. It's not silver. So you got to go to your nonmetal. Your nonmetal in this case is oxygen. And notice that you have 3 oxygens and 2 irons. Oxygen is in the oxygen family. Remember, noble gases, no charge. Halogens, a -1. Oxygen is always a -2. But you have 3 oxygens. So if I draw this out, each individual oxygen is representing a -2 charge. So I drew out 3 of them because it says Fe2O3. So my total negative charges is -6. I have 2 irons, and collectively they need to have an equal but opposite charge. So collectively these 2 irons need to make up a +6 charge. So that means that each one of them individually carries a +3 charge. Just like each of the oxygens carries a -2 charge to collectively make a -6, each of the irons individually needs to carry a +3 charge to collectively make a +6. And now when I'm going to write my charge for the iron, it's a +3. It's not a +6 because it's not the collective charge of both of the irons. It's the individual atom of the iron. And so each one has a +3. And so now I need to go and name it. And so the naming just comes straight off the periodic table. It's iron. This right here, I'm going to put Roman numeral 3 to represent the charge of my iron. And then this right here, I know that oxygen becomes oxide. Remember, uppercase, lowercase. Let's now do the exact opposite. So going from naming to compound. And this with a type 2 is probably a little bit easier in terms of identifying the charge because you already know what the charge is. It's there in the name. It's in Roman numerals. But this is where you really want to make sure you are okay with your balancing of the charges. So tin on the periodic table, there's tin on the periodic table. And I already know from the name given to me that tin has a +4 charge. Oxide means oxygen. Oxygen on the periodic table will always have a -2 charge. So I'm going to show you both ways. I'm going to show you the shortcut and I'm going to show you the long route. Let's do the long route first. So right now I have a collective +4 charge and a collective -2 charge. I'm not balanced. It's not equal but opposite. So what I'm going to do is I'm going to see what do I need to add more of. So if I add another oxygen, then now collectively I have a -4 charge and I have an equal but opposite +4 charge. So I'm balanced. My entire compound is neutral. So that means that now I'm going to use the subscripts to identify how many atoms I had. So I never write down 1, but I had 1 tin, and then for oxygen, I'm going to put down a subscript of 2 to represent the 2 oxygens that I needed. And this right now is my balanced compound. And so if I were to use the shortcut method, here's how it would work. I could just take tin with a 4+ and oxygen with a 2-. And what you do is you crisscross your charges. So I'm going to take the charge and I'm going to crisscross them and use them now as my subscripts. So now what I get is SN2O4. But this is the part that you want to really be careful with using the shortcut method. Just like in math class, it would never be okay to say 2 out of 4. You want to turn it into 1 out of 2, right? You want to always reduce. So you want to make sure that you do that if you're going to take the shortcut method. Always take an extra second and look at your integers, look at your values, and ask yourself, is there any other number that can go in here besides 1? And it has to be able to go into all of the subscripts, not just some of them. So 2 can go into 2 and into 4. So now what I can do is I can say 2 divided by 2 is 1, 4 divided by 2 is 2. So that means now that my final answer is SN, remember, never write the 1, O2. So notice that no matter which route I took, the shortcut or the long route, I should still be able to get to the same one final correct answer. You just want to make sure that you always reduce your charges. Take an extra second and do that if you're going to use the shortcut method. Okay, let's go to our last example, cobalt-3 carbonate. So cobalt from the periodic table, there it is. The name tells me that it's a 3+ charge. Carbonate is a polyatomic, and carbonate is going to have the heavier charge because it ends with ATE, so it's going to be the bigger charge. So that means that this is going to be CO3 2-. So remember what we talked about. If you see the 8 or you see the ite ending, that's your clues that you're dealing with a polyatomic. If you see the IDE ending, that's your clues that you're just dealing with a normal nonmetal straight from the periodic table. This one ended with ATE. So let's take a look over here. We have 1 cobalt and 1 carbonate so far. This is not balanced. We have a +3 and a -2. So I'm going to show this both ways. I'm going to take the long route and then I'm going to take the shortcut. So what I'm going to do first, I'm going to take the long route. First thing I want to do is I want to see who do I need to add more of. Well, right now I have 3 plus and a 2 minus. So if I add another carbonate, I now have a total of a 4 minus charge, 2 minus and 2 minus. So I have a 4 minus battling with a 3 plus. This is not equal but opposite. This is not balanced. So now what I'm going to do is I'm going to go ahead and add another cobalt. If I add another cobalt, then now I have 3 plus and 3 plus, that's 6 plus. If I go back here, check on my carbonate, I have 2 minus and 2 minus, that's 4 minus. 6 plus compared to 4 minus, I'm not balanced. If I add one more cobalt, then now I have a 6 minus charge and a 6 plus charge. So collectively, I'm equal but opposite for my overall charges. Now I'm balanced. So now I need to write out my atoms. I need to write them out as subscripts. So for my cobalt, I'm going to write it out with a 2 because I had 2 cobalts. For my carbonate, this is my carbonate, I had a total of 3. So if I do this, that's totally wrong. That's a carbon and 33 oxygens. That's not what I was trying to say. I wanted 2 cobalts and 1 carbonate. So the carbonate has to go in parentheses, and then I put a 3 on the outside, and that represents the 3 carbonates. If I were to use the shortcut for this, then what's going to happen here is I would go back to my original setup, cobalt 3 plus, carbonate 2 minus, and remember, you crisscross. Shortcut method is crisscross. So here's now how it would look. You would do cobalt, you would put down a 2, make sure you put down your parentheses, put down a 3. There's no other number that can go into both a 2 and a 3 besides 1, so this is fully reduced. So whether you take the shortcut or you take the long route, you're still going to be able to get to the same final correct answer.